Let's look at what you got here. Number 7. All right, so we got a bunch of these light bulbs. How can you build a circuit with 3 bulbs right there but disconnected? That when any one bulb is disconnected or burned out, the other 2 bulbs will go out as well. Oh, okay, yeah, good. Yes. So we call this a series. It's a circuit that's in. There's only 2 types of circuits you can have. Well, whatever. There's only 2 types of circuits you can have, and this one's called series. And look, the light bulbs are in series. That makes sense. One after the other, and specifically so let's trace it. I'll draw it as we go. This is pretty simple, and it's probably all just easy stuff, but I suppose every bit helps. So as always, okay, I'm going to draw a battery. That's where you start. Let's, over and over, just until you're sick of it. This chemical reaction in the battery produces electrons. What happens? The electrons literally flow out of this positive end out through a wire. If there's no wire, no electrons flow. Fine. So then you have a series connection. Look where this, this is what you actually do, this is what you do, engineers do. You trace the wire and you say, oh, it always comes out the positive end. Here we go. Let's see where it goes. And then, oh, look, a light bulb. And there's a little positive terminal there and negative terminal here. Oh, look at that. And then it does its thing, right? It goes through the light bulb in all these ways we've been talking about on all of them. This just happens to be this wire that you cannot see in this wooden thing. Oh, it's connected here. Or it goes to the bottom. Again, remember, bottom side, can't be side. So let's say it goes into the side. Filament, and it does its thing, like always. It flows through here. It's got to come out the bottom if it came in the side. And then it's connected to that terminal. And you say, oh, what happens now? I don't know. But in series, we have to, then you say, oh, I'm going to add, well, if this is, I don't know if you guys did this much, but if that's positive, well, that better be negative. You have to match each end of the wire, positive, negative. This cannot be the positive side, as far as you're concerned. And then you got your other thing here. And guess what? Oh, in series, I want to continue connecting these light bulbs, whatever it says, that when any bulb is disconnected. So we should talk about that. But then, oh, another wire. And so if this is positive, this is negative, that's positive, this is negative. Each wire has to be connected positive and negative. Oh, and then you got to, I don't care. Let's add 100 light bulbs in this way in series, one after the other, wire. You have 3, obviously. And then, well, you better come back. The whole point is you complete the circuit. Because the circuit is complete. Why? Because the positive has a positive, or has a wire, negative has a wire, cool. And everything in the middle here is going okay. Our wires are connected. The circuit is complete. And so if you remove a light bulb without changing any wires, well, yeah, you're going to break the circuit. The circuit will not be complete if you remove that middle bulb. What you would do is you connect oh, okay, I don't care. I'm going to just take that wire. Look, I got an extra wire now, but that's not what they're saying. You don't do that. You got a broken circuit, right? And it looks like you did that. And hopefully, I'm not sure if you did that on your own, but I mean, it's pretty easy to understand, right?
Yeah.
But that's the full picture. Once again, probably a little more than you need. Let's read the conclusion. When there's a gap in the circuit, open circuit, it's called, right? Open just means there's a missing piece. By placing the bulbs in a line with a single wire connecting the bulb to the battery and each other. Oh, this is pretty cool. So you can either have series or parallel. This is series, again, bulb one after the other, bulb one after the other, right? That's series. The reason your Christmas lights don't burn out, because, oh, look, I mean, I unraveled it. Look, these are obviously in series. That's what it looks like, but they're actually in parallel. That's why one can burn out and the rest stay. Because you say, well, why don't my Christmas lights burn out? If this experiment is true, because this physics should apply to this experiment and anything else in series. And the answer is those Christmas lights are not in series. And so this is exactly what you have in number 8. This is called parallel.
Okay.
Yeah, I mean, that's pretty much the only way you can do it. It looks a little weird. I'm just used to resistors, I guess. You know, you don't draw light bulbs. Usually you draw the, resistor. It looks like that, but obviously light bulbs resistor. But you see how it's like the positive end of the battery. Again, there you go. Bam. You're tired of me yet? Chemical reaction produces electrons, produces a voltage. The voltage pushes the electrons to create a current. What happens? Well, we have a wire, electrons are flowing because of that voltage. And now, yeah, you got it. See how it's not connected? What happened before? In the series, it was like this, where, oh, there's my wire, new wire. But now this same wire here, you're not connecting one to the positive. You are, yeah. You're touching all the, well, alternating positive, negative, but you're going here and then you come around and go back to the negative. I didn't draw it great, but I should just draw what you had. But is that kind of clear? I mean, the difference between series, because if you understand series, which is pretty easy, it's how we think normally, and parallel is pretty confusing, but it's just, you're touching all of the bulbs at once. That's what's happening.
Okay.
Because go back and look at your series and you say, what did I just say? You're touching all the bulbs at once in parallel, but look, the battery is touching a bulb and then that next bulb, like in succession, right? But instead the parallel, you literally have all the bulbs touching the positive terminal at once. Even though it doesn't really look like that. That's the opposite of series.
Mhm.
And that's exactly, the question, have them burn out. Any one of them can burn out. Two of them can burn out and you can still get that other one. Why? Because the circuit's still complete. The only way that's possible if all three of the bulbs are touching the positive at the same time.
Okay.
I think that's a decent way to think about it. And then, of course, the negative ends of the bulbs, every single bulb is touching the negative end of the battery at the same time, rather than in succession.
Okay.
And that's why the Christmas lights work when one burns out, because they're not in series. What happens if you're series? Go back to your conclusion. Open circuit. It's broken because they're connected in succession with each wire.
Okay.
Do you want to? Is it good, or do you want to go through it again?
It's starting to make a little more sense. Yeah.
Okay. I mean, if you read these conclusion, new information, the key here, let me write those words down for you if you didn't. And that's the only two, obviously, as you've seen, you only got 7 and 8. But I mean, that's already, about kind of the first half of the whole college physics on resistors.
Mhm.
Because there's only series and parallel, unless you're a badass engineer.
Mhm.
So let's just go through it again. I think you got the series. And so if I do, let's do your picture. Batteries create voltage. What does voltage do? It pushes electrons outward. The flow of electrons is current, but the flow of electrons is electricity. And so if you have bulbs, remember how in series, this wire would go and we would connect this battery. And then we have another battery. Oh, we have to connect another wire in series, in succession. And then finally, I don't care how many batteries you have, you can do it to 1 million. it's got to go back to the end of that. I'm sorry, it doesn't matter how many bulbs you have, but that last battery, oh my God, that last bulb better touch the end of the battery. That's
Mhm.
series. That's series. We're talking, but now I want to talk about parallel because it's not that. It's the opposite of that, where, well, we got this wire, and instead of going like this, right, it's going to literally, you could kind of think about it as branching out and going here, and then, oh, it's going to touch all of them simultaneously. That's not too bad. It's not a great way to draw it, but it's a good way to think about it. You know what I mean?
Yeah.
And just go back to that previous slide, right? It's the positive end here is literally touching all of the light bulbs at once at the same time. And that's what I tried to draw here. Again, you can have 100. It's going to touch all 100 of them at the same time.
Mhm.
And of course, like what I mean by this is not a great drawing. The drawing that you have there is much better because that's more realistic. You know, you can't split up a wire into 3 wires. You know, you can, but you don't. You don't do that. You know what I mean? And so you have to set it up the way you set it up there, which is connecting each of the positive ends, essentially. I'm sorry, the negative ends. Because remember, the positive end of the battery better touch the negative end of the light bulb.
Yeah. Okay.
So if I could get on your paper, I would put little minus signs on the right side of every light bulb. There'd be a minus sign on that first, second, and third one. And then the positive end of the batteries would be on the left side.
Mhm.
So yeah, that's all I got on that. So hopefully that's clear.
Yeah, it is.
Okay. Do you want to start going over your final stuff? Or do you want to wait? Or if you even need to do that, I don't know.
I think I want to wait until after I take my test, just so I don't like lose.
Yeah, mix it up. I know what you mean.
Yeah. I don't want to like forget this information.
Yeah, for sure. Yeah, I obviously have other classes too. So it's not like, it's amazing how much they expect you to know, you know what I mean? Like in high school,
Yeah.
like so much stuff, especially if you're taking like biology and physics and then all your other crap, English and social studies and all that other stuff, right?
Yeah.
Yeah. Okay, so what do you think? Do you want, I wish there was like a math problem we could do. I guess there's that Coulomb's law one, but what do you think we should do right now?
I don't know. I think I'm actually pretty set. Like this all makes sense to me.
Okay, good. We can go through it again. I could also, I don't know how it worked last time. Like I said, this is kind of Matthew's gig, you know, so because last time we kind of ended early and then I was like, yeah, I don't know, we'll give you
Yeah.
credit or whatever. I don't know if that happened, but we could do that now. If it did happen before, I'm not sure, but
Do you think that we could use some of this time for like after my test to study for finals?
yeah, well, like I said, do you know if we did that last time? Because we talked about it,
Um,
but like I said, this isn't really my gig. You know what I mean? Like Matthew's kind of in charge of all of that,
oh, okay.
over the administrative and the billing and all that stuff. You know what I mean?
Yeah. I don't think we used that time from last.
Okay. Why
From
don't
last.
you, I'll mention something to him before, because I mean, that would be an hour. You know what I mean?
Yeah.
Probably if we stop right now, because what is that, 30 minutes here? And then I know we had at least 20 minutes last time. So
Yeah.
if we
Okay.
didn't use it, so you know, maybe ask him, lean on him a little bit, maybe, I don't know. But I'll definitely mention something too.
Yeah. Okay.
And see if we can get that going. All right. Well, good luck. And yeah, I'll talk to you soon a bit.
Okay. Thank you so
Of
much.
course. Bye.
Bye.